Welcome. You're receiving this video because you have points to recover from the Geometry B Unit 2 test. Note that the questions on this video are like the ones on the test, but not the same as the ones on the test. That is to protect the veracity of the test itself. To recover half your missed points on your test, take detailed notes, that is, write the question and all the steps and work that I show on the question, and then submit those notes either attached to a webmail or sent as a picture through text. Make sure to include your name and what assignment this is for if you do send it by text, so that I have more than a telephone number to go by. Without further ado then, question number 1. A right triangle has a hypotenuse of length 8 square root 2 and an angle of 45 degrees with a side opposite this angle with a length of 8. A second right triangle also has an angle of 45 degrees with a side opposite this angle and a length of 15. Right? The key here is, and this is the way they expected you to solve it, was to note that the two triangles have two matching angles, a 90-degree angle and a 45-degree angle. Therefore, by the angle-angle similarity postulate, these two triangles are similar, and you can write a proportion. And there's lots of ways you can write the proportion. You could write 8 is to 8 root 2 as 15 is to x. And let's go ahead and do that. 8 is to 8 root 2 as 15 is to x. And then cross multiply. 8x equals 15 times 8 root 2. Divide by 8. 15 times 8 root 2. Divide by 8. Notice that some things cancel. The 8's cancel. And we end up with 15 root 2. Now, that is the way they expected you to solve it, and that's perfectly fine. But I do want to show you this can be solved much easier by using the 45-45 reference triangle. In the 45-45 reference triangle, the sides are 1, 1, and root 2. If you know a leg and need the hypotenuse, simply multiply by square root 2, multiply by square root 2, and the answer is 15 root 2. Simple one-step method to find it. Go ahead and jot down the notes, of course, for both. All right, question number 2. A plane is descending at a 14-degree angle of depression. If the current altitude of the plane is 1,200 feet, find the distance the plane still needs to fly to reach the ground. This is one of those cases where a drawing is really beneficial. So we have an airplane traveling along, and it's got an angle of depression. That means from the horizontal, it's angling down at a 14-degree angle. So it's traveling downward like so. And 14-degree angle of depression. It is currently 1,200 feet above the ground. 1,200 feet above the ground. So this angle is 14 degrees. That means alternate interior angles are parallel. This angle is 14 degrees. This height is 1,200 feet. And we're looking for this angle, this length right here. We'll call this x. Now 14 degrees is the reference angle. Okay. 14 degrees is the reference angle. Then the side opposite the 14 degrees across from the 14 degrees is 1200. Opposite. And the long diagonal is always the hypotenuse. So we need opposite and hypotenuse. Remember SOHCAHTOA, that is so. Sine of 14 degrees equals opposite 1200 over hypotenuse x. You may recall when the x is in the denominator, we can simply switch. X equals 1200 over sine 14. So x is approximately 1200 divided sine 14. Bring up Desmos. 1200 divide sine 14. Do check and make sure that you have set Desmos to degree mode by clicking the wrench tool. It currently is because I've already had it open. 4,960.3, so I'm going to round it to the nearest foot, 4,960 feet. Is how many feet to the nearest foot the airplane needs to fly to reach the ground. Okay, and that was question number 2. Okay, number 3. A 15-foot ladder leans against a wall so that the ladder's angle of elevation is 46 degrees. If is 46 degrees. Find the distance from the base of the ladder to the building. From the base of the ladder to the building. So angle of elevation is an upward-looking angle instead of an angle of depression, which is a downward-looking angle. So a 15-foot ladder leans against the wall, so the ladder's angle of elevation is 46 degrees. So the angle up the wall, you drive me up the wall, is 46 degrees. So 45 degrees would be perfectly diagonal, so it's slightly steeper than that. So it's something like this. So it's leaning up. And the wall, of course, is assumed to be vertical, as walls are wont to be. Poorly built walls may not be, but correctly built walls usually are perfectly vertical. We have tools like plumb lines to make sure that they are so. Okay. So 46 degrees, and the ladder is 15 feet long. Find the distance from the base of the ladder to the building. Let's call that x. Okay, let's name the sides. To name the sides, we name them hypotenuse, long diagonal. The side adjacent or touching the 46 degree angle is the adjacent. So we need to know the adjacent. We know the hypotenuse, adjacent, and hypotenuse. Think of our mnemonics, SOHCAHTOA. SOHCAHTOA, this is ka, cosine of 46 degrees equals adjacent over hypotenuse 15. Multiply by 15, x equals 15 cosine 46. So x is approximately, let's go ahead and do this here to the nearest hundredths. Cos 46, and making sure our calculator's in degree mode. Mine is 10.419 is 10.42. 10.42 feet out from the wall. And that is actually a very shallow angle to put a ladder up. Usually you want to put your ladder up a bit steeper. You run the risk of having the footing of the ladder slide out and the top of the ladder slide down the wall when you put it that far out away. Alright, that's number 3. Okay, number 4, you're given a funny looking looking drawing of a right triangle where the sides are labeled A, B, and C, legs A, B, and B, and hypotenuse C. And then you've got two reference angles mentioned. You have the Greek letter phi, P-H-I, that's this circle with a diagonal slash through it, and the Greek letter theta. Mathematicians are prone to using Greek letters because there's not enough letters in the alphabet, the English alphabet, so we use Greek letters. And theta and phi are the reference angles here. Just letters, that's all they are. They're just funny letters. If C equals 21, let's label that, C equals 21, and B equals 18 inches, 21 inches and 18 inches, find sine theta. So sine theta. We're going to use the mnemonic SO. Sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So theta is named as our reference angle, and this is really critical. We've got to get the right reference angle. Here's theta right here. So this is the hypotenuse. The opposite is across from theta. It doesn't touch it. It's opposite it. And the adjacent touches it. So opposite over hypotenuse is A over 21. There's a problem. A over 21. We don't know what A is right now. Therefore, we've got to use the Pythagorean theorem to find it. So the Pythagorean theorem says A squared plus B squared equals C squared, literally the way it is right here. A squared plus B squared, 18 squared, equals C squared, 21 squared. Okay. And let's see here, A squared equals 21 squared minus 18 squared, square root. Alright, and let's go ahead and bring up Desmos here. Let's find out what this is. Square root, 21 squared minus 18 squared. And this one's not a perfect trinomial, or a perfect Pythagorean triple. 10.81. Let's go to the nearest under 10.82. Okay, and so the sine theta is 10.82 divided by 21. And we're going to leave it just like that. That's our sine ratio. All right, number 5. Fritz is looking at the top of a bell tower that is 120 feet away. Now, there's a little bit of a question about reference here. What is the 120 feet? Is the top of the bell tower 120 feet away, or is the bell tower itself 120 feet away? In the context of the problem, which was about a flagpole in your test, they're talking about the distance to the base. Just taking that in context. So Fritz is looking at the top of the bell tower, and the base of the tower is 120 feet away at an angle of elevation of 36 degrees. What is the height of the bell tower and the distance between Fritz and the bell? So here we go. Let's go and draw a triangle that represents this situation here. Fritz is looking up at an angle of 36 degrees. That's something like this or so. 36 degrees. Looking up at the top of the bell tower. And the base of the bell tower is 120 feet away. So 36 degrees, 120 feet. And what is the height of the bell tower? We'll call that H. And what is the distance between Fritz and the bell itself? So we'll call that D. Okay. And so the reference angle is down here at 36 degrees, so D is the hypotenuse. H is the opposite side, because it doesn't touch the reference angle. And 120 is the adjacent side. It touches the angle. Okay, so to find the opposite, I'm going to use opposite and adjacent, because I know the adjacent. Opposite and adjacent is OA, so SOHCAHTOA, TOA, that's TOA. So tan of 36 equals opposite, H, over adjacent, 120. Multiply by 120, so H is 120 tan 36. Now I'm going to save reaching for a calculator for right now because I also want to go and find the hypotenuse as well, the distance between Fritz and the bell. And so I'm going to use hypotenuse and adjacent, adjacent and hypotenuse, adjacent and hypotenuse. Think SOHCAHTOA, that's ca, that's cosine. So cosine 36 is adjacent 120 over hypotenuse d. Now in this case, the denominator is the variable, so we're just going to switch places here. D equals 120 divided cosine 36. Okay, now I'm going to reach for a calculator and find H and D. Okay, so Desmos, here come the Desmos. Who's the Desmos? Not the Desmos. And we're going to do H, which is 120 tan 36. 87 point, I'm going to go to the nearest tenth, 2, 87.2 feet. That's how high the bell tower is. That's pretty big. That's almost 9 stories. Right? And then the D is 120. Divide cosine 36, 148.3. 148.3 feet. So let's go ahead and label these on the drawing here. 148.3 feet. And 87.2 feet. Okay, and check for reasonableness. 148.3 is more than 120. That's good. 87.2 is definitely the shortest side. That's number 5. Number 6, if an equilateral triangle has a perimeter of 45, what is the length of the perpendicular bisector of any of its sides? Well, there's a lot of vocabulary to parse out in there. Equilateral, first of all, means all sides are the same length. So I've drawn an equilateral triangle. Last semester, you may recall, we did a construction of an equilateral triangle in a circle. So I used the circle to draw it. And equilateral, all those sides are the same. So this side is the same as this side is the same as this side. All 3 sides are the same. All 3 angles are 60 degrees. 60 degrees, 60 degrees, and 60 degrees. Now, the perpendicular bisector of any of its sides. So the perpendicular bisector basically is where we take and draw a line that is perpendicular to the side and bisects or splits it in half. That basically is this vertical line right here. It's also the same as the altitude of the triangle, and it is the same as the angle bisector of the triangle because all 3 lines are the same in a equilateral triangle. Now, perpendicular bisector technically is an infinitely long line. It just goes forever. By length of the perpendicular bisector, one has to make the assumption that they're talking about the distance between the vertex and the midpoint. In other words, this height, this length we'll call h. Okay. So leaving that in mind here, and this 60-degree angle is split in half, so this is 30 degrees. So this is a 30, 60, 90 triangle. And so we can use the 30, 60, 90 reference triangle to solve for it. But before we do that, let's go ahead and parse out this 45. 45 is the perimeter, right? And so perimeter is 45. That means each side must be 45 divided by 3. So let's call the side x. 45 divided by 3 is 15. So that means this length is 15, and this length is 15, and this whole length is 15. So this half length is 7.5. 7.5. Okay. All right. And so let's use what we know about a 30, 60, 90 triangle. You may recall that in a 30, 60, 90 triangle, the sides are 1, 2, and root 3. If we know the short leg, then the long leg is times root 3. So the height here is 7.5 root 3. And that is the answer to the question. What is the length of the perpendicular bisector? H equals 7.5 root 3. All right, number 7. Number 7 on the test was about a baseball field. Well, I'm going to change up the problem here. This is for a women's softball field. In women's softball, the distance between the bases is 60 feet. So if the catcher needs to throw the pickoff throw from home plate to second base, how far does the catcher need to throw the ball? You may recall that the angles are all square corners, and so this actually is a square, and this is the diagonal of a square, which is split in two, which is 45 degrees and 45 degrees. So this is a 45, 45, 90 triangle. And you may recall that in the 45, 45, 90 triangle, the sides are 1, 1, and root 2. So if I know a leg, then to get the hypotenuse, I multiply root 2. So the distance of the throw is, we'll call this D. The distance of the throw is 60 root 2. And it is that simple. Let's go ahead and get an approximation here. 60 times the square root of 2 to the nearest foot. Find out how far that is. 60 square root of 2, SQRT2, is 84.8, so 85 feet to the nearest foot. 85 feet. Exact, 60 root 2, 85 feet is approximate. Okay, question number 8. We're given a drawing of a triangle, ABC, with the altitude drawn from B, labeled little h. Little a is across from angle A, little c is across from angle C, and little b is across from angle B. And we're told a few things about this particular A triangle here. We're told that A is 42, so let's label that 42. And let's say it's centimeters, 42 centimeters. Angle C is 28 degrees, 28 degrees. And we want to note the side H. Well, here's our right triangle right here. Right here. Right triangle. Boom. Okay, so we have a reference angle. So H is the opposite side, and A is the hypotenuse. Opposite and hypotenuse is SOHCAHTOA, so sine of 28 degrees is opposite H over hypotenuse, 42. Multiply both sides by 42, and H is 42 sine 28. So H is approximately 42 sine 428. So let's bring up our calculator. Make sure it's in degree mode, of course. If you do that once, you don't have to do that again until you reopen Desmos. So 42 sine 28. 19.7. Let's go to the nearest whole centimeter, 20 centimeters. So H is 20 centimeters, 20 centimeters. Okay, and that's number 8. All right, Elmira wants to buy sand for a triangular sandbox. Two of the sides of the sandbox are 8 feet and 7.5 feet. The angle between these sides is 48 degrees. What is the area of the sandbox in square feet? Let's go and do a little bit of a scale drawing here so we can understand what it is we're talking about. We're talking about a sandbox that has one side that is 8 feet long. 1, 2, 4, 6, 8 feet. Okay, and another side that is 7.5 feet long and an angle of 48 degrees. Here's 45 degrees. 48 would be something like this. Okay, and this side is only 7.5 feet long. So let's grab our compass here and set it to about 7.5. Right about here. So cut it off right there. There we go. And draw the third side. So the sandbox looks something like this. Where this is 8 feet, this is 7.5 feet, and this is 48 degrees. And we're looking for the area of the sandbox. The area of the sandbox. Okay. Now this is a question asking directly for a use of this formula. A equals 1/2 AB sine C. So A is 1/2 of 8 times 7.5 times sine 48 degrees. And now reach for a calculator. Approximately 1/2, right arrow, 8 times 7.5 sine 48. 22.29, I'm going to go to the nearest tenths, to 22.3 square feet. And if I wanted to know how many cubic feet that is, if I vary it to, say, a depth of 6 inches, which is half a foot, I'd divide that by 2, basically about 11 cubic feet, and there's 27 cubic feet in a cubic yard. So that's not many cubic yards. Not too bad. But all you were asked for was the area. All right, this next one is an essay question. It's a bit of a doozy. It says, right triangle ABC has side lengths AB equals 24, BC equals 10, and CA equals 26. A second right triangle has corresponding vertices of A prime, B prime, and C prime with side lengths of 15, 36, and 39. Describe how to find the ratio of the side opposite angle A to the hypotenuse of triangle ABC. Then use this ratio to identify the location of point A prime in the second right triangle. Okay, so let's parse this out and let's break this down into pieces, into chunks. And we definitely need a picture to see what's going on. So we need a right triangle. ABC is a right triangle. It's got a right angle. It has side lengths of 24, 10, and 26. The longest of those is 26, so that's got to be the hypotenuse. So let's just sketch here. Right triangle. Okay, 26 is the longest side. 24 is the second longest side, and 10 is the shortest side. Okay, AB is 24. BC is 10, so this has got to be B. And AB, and AC is 20, or CA, AC and CA are the same as 26. So there's a picture of our first triangle. The second right triangle has corresponding vertices of A prime, B prime, and C prime with side lengths of 15, 36, and 39. Okay, so bigger sides. So let's sketch our triangle here. Okay, and let's label the sides here. Their corresponding parts, A prime, B prime. B prime has to be 90 degrees, and C prime. Now, what we don't know is which is A, B, and C, where the side lengths go, 15, 36, and 39. The longest is 39. That's got to be the hypotenuse. Okay. And in order here, the shortest side is the vertical side, so the shortest side has to be BC, so the shortest side has to be 15. And the remaining side is 36. So actually, I already know which angle corresponds to angle A prime. The location of A prime is right here between the 39 and the 36. We just get that by reasoning by proportion and proportionality. But we had asked us to describe how to find the ratio of the side opposite angle A. So opposite angle A, so opposite angle A is the 10 side, opposite over the hypotenuse, opposite over hypotenuse. That's sine. Okay, and so the sine of angle A is opposite over hypotenuse, 10 over 26. 10 over 26. Which reduces by 2 to 5 over 13. So sine of A is 5 to 13. Use this ratio to identify the location of point A in the second right triangle. So I want to verify the sine of A prime is the same. Sine of A prime is opposite 15 over hypotenuse 39. Reduced by 3, we get 5 over 13. They are equal. Therefore, I've identified the correct angle. Sine A is right there, and its ratio is 5 to 13. Sine A prime, its ratio is also 5 to 13. All right. Last question. All right, we're down to it, the last question. In a right triangle, the acute angles have the relationship sine of 10 plus x is the same as or equal to the cosine of the quantity 2x minus 40. What is the value of x? What is the measure of the smaller angle? This comes from this relationship that comes from a right triangle. Let's say we've got a right triangle here. A, B, and C, where A and C are the acute angles. Okay, and what it says basically is this: sine of angle A is the same as cosine of angle C. I can verify that if you like here. Little a, little b, little c. Sine of angle A, if A is the reference angle, so opposite over hypotenuse. Sine of angle A is little a over b. Cosine of angle C is opposite. Now this is the reference angle. Opposite C over hypotenuse. Adjacent cosine. Adjacent adjacent over hypotenuse is A over B. So both sine A and cosine C are little a over little b. So the sine of one of the acute angles is equal to the cosine of the other acute angle. Now there's another relationship in these angles here. The acute angles of a right triangle, the measure of angle A plus the measure of angle C is 90 degrees. They are supplementary. They add to 90 degrees. And that comes from the triangle angle sum theorem. Remember, the angles of a triangle must add to 90, or to add to 180. One of them is already 90. So take 90 away from 180. 180 minus 90 is 90. The other two have to make up the 90 degrees between them. So the two acute angles of a right triangle are always complementary. They always add to 90 degrees. So if the sine and the cosine equal each other, then their arguments must, by this logic here, add to 90 degrees. That is to say, 10 plus x and 2x minus 40 must add to 90 degrees. 10 plus x plus 2x plus minus 40 equals 90. Combine like terms, 10x and 2x, or 1x and 2x is 3x. 10 minus 40 is negative 30 equals 90. Add 30 to both sides, so 3x is 120. Divide by 3, and x is 40. So there's the answer to one of the questions. What is the value of x? X is 40. What is the measure of the smaller angles? Now we got to substitute this back in. 10 plus x, or 40, is the measure of one of those. That would be 10 plus 40 is 50 degrees. And the other is 2x, 2 times 40 minus 40. 2 times 40 is 80 minus 40 is 40. And the 40 is smaller than the 50, so the 40 is the smaller of the two angles. Okay, and there we have it. A lot of gymnastics going on there, mental gymnastics.